Hi all. Before the break, I was really happy to read about how in your reflections you were feeling really good about factoring. I want to keep that as a strength and just review problems 453 and 461 before prompting you to go on with some more factoring. So I'm in 453. We're going to review the first, basically just three ways that we've talked about factoring so far. The first one being just setting up your parentheses and looking for factors of this C value that will potentially add up to 9. So factors of 20 are 1 and 20, 2 and 10, 4 and 5, 5 and 4, 10 and 2, 20 and 1. The factors that add up to 9 are either this one or this one. You can pick either order, it doesn't matter. And then in this case, we would set up x and x, 4 and 5, or 5 and 4. And that should be it, but let's check by distributing x to both these places. So x squared plus 5x, and then distribute the 4. Nice. X squared plus 5x, plus 9x plus 20. Beautiful. Okay, so our final answer, the way we would submit it, is like this, and highlighted for our final answer. The other way with a harder problem that we've talked about is using that X method, and then factoring by parts. So I'll set up the X box here. And then this is A times C, and this is the B value. So remember, this is our A value up here and our C value here. So that would be 3x squared times negative 4. That's negative, wrong color, negative 12x squared. And then our B value is just what's in the middle, so that's plus 1x. So as we go to fill in this component of our chart, we're looking for something that multiplies to negative 12x squared and adds to positive 1x. So already I'm thinking about 3 and 4. I want it to end up positive, so I'm going to do a positive 4x and a negative 3x. And if those guys were multiplied together, I'd get negative 12x squared. That works well. So I'm going to rewrite my original A and C, 3x squared minus 4, but then I'm going to fill in that B value, plus 4x minus 3x. Now I want you to notice that this B value of plus 1x is the same B value that we started with, plus 1x. So we haven't actually changed the equation at all, but we've rewritten it in a super helpful way, because we're going to go ahead and divide it down the middle, factor out what's common on the left side, which is an x, leaving behind 3x plus 4. On the right side, factoring out what's common, negative 1, leaving behind a 3x plus 4. Now, wonderfully, 3x plus 4 is common to both, so let's factor that out. 3x plus 4, that leaves behind x minus 1, and we're done. We factored it. Lovely, lovely. And finally, x squared minus 81. I recognize this as a difference of squares. This is a square that's x by x, and this is a square that's 9 by 9. Right, so I can rewrite this as x squared minus 9 squared. And I know this pattern, x minus 9 times x plus 9. And of course, you can check that out by multiplying it. If you distribute the x through, and then the negative 9 through, you'll get x squared minus 9x plus 9x minus 81. Okay. So there's my review of factoring. The three ways, basically the first one in part A, using the factors of the C value because there's no A value to deal with. Part B, setting up an X box, and part C, using the difference of squares pattern. Now in 461, we want to take factoring a step further and use it to solve equations that have a quadratic on the left side, so some kind of quadratic expression equaling 0. The zero product property, ZPP, is something we're going to use a ton, and we love it. It works so nicely. So we'll review it here. I'm going to factor the left-hand side to start. And this one I can use the fact that negative 8 is made up of 2 times 4, or 8 times 1. 2 times 4 works better for us. I want a positive 4, negative 2, x and an x. Now, the zero product property, remember, says if I have a times b equaling 0, so if this is true, then a equals 0 or b equals 0, right? Because, or both, because you have to have something multiplied by 0 to equal 0. So if a equals 0, that means the term x minus 2 equals 0, which means that x equals 2 would potentially, or would definitely send this equation to 0. Separately, if I look at the b term, x plus 4 equals 0, well, if x equals negative 4, that would send that whole term to 0. So my answers for what sends this whole equation to 0, either negative 4 or 2 would work. So that's how to use factoring to solve the zero product property problem. Look at, I forgot to put an N on then. Sorry. Alright, part B. X squared minus x minus 20 equals 0. I'll move this over here. I can factor that one. X, factors of 20. Again, I'm looking at 1 times 20, 2 times 10, 4 times 5. Ooh, that looks good. 4 times 5, with the 5 being negative and the 4 being positive. Perfect. So now I'm looking at what number sends this term to 0. Well, that's if x equals negative 4. What number sends this term to 0? That's if x equals 5. So the answer to B is x equals negative 4 or 5. Either one would work. And for part C, I get to notice the difference of squares pattern again. So I know that that's 9 squared minus x squared. I know that has to be 9 minus x times 9 plus x. And the x value that would send this term to 0 is 9. The x value that would send this term to 0 is negative 9. So the answer to part C, what is the x value that would send 81 minus x squared to 0, would be either negative 9 or positive 9. I hope this review's been helpful. The next problems to try out with these ideas. So next up, I want you to work on number 506 and 507. All right, thank you for your attention.